It's June 2026.
Yeah.
And I've been thinking a lot lately about the line between a tool and a teammate. Beat. We are so used to AI acting like this eager, lightning-fast chatbot.
It's just answering our immediate questions.
Exactly. But what happens when that dynamic fundamentally shifts? Like when a model stops behaving like a junior dev just grabbing snippets of code.
And starts acting like a senior software architect.
Right. Managing a massive multi-step project from start to finish. Welcome to the Deep Dive. I'm really glad you're here with us today.
So glad you're here.
Our mission today is to unpack Anthropic's Claude Opus 4.8. We're going to strip away the marketing. We really want to understand what this means for you and your development workflows.
We have a ton of ground to cover. Today is all about exploring how this specific model fixes that notorious lost focus problem.
Which definitely plagued Opus 4.7.
Oh, absolutely. We're going to break down some genuinely wild real-world stress tests.
Like the browser stuff.
Yeah, building a fully functional macOS clone right in a browser. And then we'll examine the real-world costs of these agentic workflows. Because high-effort reasoning tasks are, they are not free.
No, they certainly aren't. It's going to be a fascinating journey. Let's get right into what actually changed under the hood in Opus 4.8.
Let's do it.
But to really appreciate this architectural leap, we kind of have to look back at the pain points.
For sure.
If you're a developer listening to this, you know the exact frustration we were hitting with Opus 4.7, especially during real extended work sessions.
The sunk cost fallacy with 4.7 was just so real. It struggled incredibly hard with long, persistent coding tasks.
It really did.
You'd spin up a Claude code session, feed it a complex repository, and, well, it'd start strong.
Always start strong.
Right. But over extended periods, it simply lost focus. The context window would bloat, the token usage climbed exponentially, and worst of all, its reporting became wildly unreliable.
I have to admit something here.
Yeah.
I still wrestle with prompt drift myself.
Oh, everyone does.
You know, you start a long project, you give the AI crystal clear instructions, you lay out the exact tech stack. But 20 prompts deep, you realize it completely lost the plot. It starts pulling in deprecated libraries. Or it just forgets the core architecture you established in prompt 1.
It's the universal headache of the last 2 years. Opus 4.7 would do this thing where it gave you a progress report that sounded incredibly confident.
Confident hallucinations.
Exactly. It would say, I've successfully wired up the database schema and linked the user auth.
But it hadn't.
Right. If you actually check the commits, parts of the logic were just a hallucinated mess. Large generations became highly expensive.
Because you're burning tokens on higher reasoning settings.
Yes, only to end up debugging a phantom application. Opus 4.8 is Anthropic's direct engineered response to that specific hallucination loop.
So the focus has fundamentally shifted toward long session stability.
Completely.
It's not just about acing a static benchmark screenshot anymore. It's about holding the line over a 4-hour coding sprint.
Yep.
They've aggressively targeted honesty and self-correction.
It's a massive operational shift in how the model evaluates its own latent space, which is basically its internal map of concepts.
Right.
Opus 4.8 checks its own outputs against its initial constraints much more frequently. If it hits a snag during a long session, it actually reports uncertainty now.
That's a huge deal.
It is. It stops and says, I can't resolve this dependency, instead of just faking a completed step and hoping you don't notice.
It drastically reduces those inaccurate progress reports that used to drain our API budgets.
Yep.
It feels like an intern who finally learned the hardest lesson in software engineering.
Which is?
They actually pause to double-check their logic before handing in the assignment, rather than just nodding and smiling.
Yeah, the days of the eager pleaser model are fading, and the benchmarks actually back up this shift in behavior.
The SWE-Bench Pro numbers.
Exactly. On SWE-Bench Pro, Opus 4.8 hit 69.2%. It edged out GPT 5.5 and Gemini 3.1 Pro on that specific metric. But the score itself isn't really what matters. What matters is the mechanism driving it. Which brings us to the new effort control feature.
Right. Effort control. Users can now manually adjust the reasoning depth for each specific task.
Yes.
And this directly dictates token consumption and output stability.
You're essentially giving the model permission to pause, to run internal chain of thought routing before it spits out a single line of thinking.
So low effort and high effort workflows produce wildly different architectural decisions.
Wildly different. Higher effort creates much more stable, production-ready results.
Yeah.
But it burns through your token limits fast.
Because it's generating thousands of invisible reasoning tokens to plan the work.
Exactly.
Let me ask you about the practical side of this dynamic. If I'm building a SaaS platform this weekend, how do I actually balance this effort control without bankrupting my API account?
You have to become really strategic about task complexity. If you're just formatting a JSON file or writing simple CSS wrappers, keep it on low effort.
It doesn't need to think hard about that.
Right? The model knows how to do that instantly. But if you are doing multi-file architecture planning or setting up database schemas, you crank that slider all the way up.
Got it.
The AI spends significantly more computational time planning the node connections before generating the syntax. You are paying a premium for that extended, invisible planning phase.
So you're literally trading more tokens for deeper thinking.
Right, and it changes how we structure our builds entirely.
Let's look at what happens when you push that deeper thinking to the absolute limit.
Oh, this is the fun part.
It's one thing to score 69.2% on a benchmark at a vacuum. It's another thing to build complex ecosystems from scratch.
Truly.
The real-world stress tests for Opus 4.8 are, frankly, incredible.
The Minecraft clone test is probably the best illustration of this. The prompt was aggressive.
Very aggressive.
It asked the model to build a fully playable browser game, complete with terrain generation, chunk loading, cave systems, and a working inventory block swapping mechanic.
And it had to do it inside a single HTML file using WebGL. That is a staggering cognitive load for one continuous file. Managing the game loop, the rendering logic, and the user state all in one massive document.
It's a context nightmare. When they ran this on Opus 4.7, it completely broke down on the terrain mapping and the inventory state.
It just couldn't handle it.
The workflow consistency shattered as the file size grew. It would generate the terrain, but when it tried to add the inventory array, it corrupted the rendering loop.
But 4.8 was different.
Opus 4.8, running on high effort, maintained that gameplay logic smoothly for the entire session. The world structure and the JavaScript arrays stayed completely clean and isolated.
Even as the file approached 10,000 lines.
Yep.
Then you have the MacOS clone demo, which tests a totally different kind of logic. Building a browser-based operating system?
Yeah, that one is wild.
You got Finder windows, a functional terminal, drag-and-drop state management, and a global dark mode toggle.
This is where state management usually kills language models.
Yeah.
Opus 4.7 lost UI consistency the moment new apps were added to the desktop. You'd open the calculator, and suddenly the z-index, the visual stacking order of elements of the Finder window, would break, or the styling would bleed into the terminal.
I'm just confused.
But Opus 4.8 kept the window states behaving naturally. It managed the DOM elements and the connected UI systems flawlessly.
The 3D dungeon crawler test was even more revealing to me, just from a pure computational standpoint.
Yeah, that's my favorite comparison by far. The prompt demanded procedural dungeon generation with raycasting, alongside pathfinding logic for enemy AI.
And how did 4.7 handle that?
Opus 4.7 basically faked it. It made what felt like a 2D layered UI. It was static, top-down gameplay elements just visually layered on top of each other.
Using CSS transformations.
Exactly. Opus 4.8 didn't fake it. It actually built a real 3D environment using matrix maps.
That's insane.
It generated first-person camera movement, mini-maps that tracked coordinate data, and interactive combat HUDs that responded to field-of-view mechanics.
Whoa. Beat. Imagine it building an entire 3D ecosystem from one prompt, 2 sec silence. It's almost difficult to wrap your head around what's happening in that latent space.
It really is. And the same spatial awareness translates to its front-end generation, too.
How so?
It builds production-ready SaaS landing pages beautifully because it understands spatial hierarchy now. It generates complex animated SVG dashboards much faster.
So the layout is actually good.
The visual hierarchy, the actual padding, the typography scaling, the contrast ratios is noticeably cleaner and more modern than anything Opus 4.7 could output.
I want to circle back to the macOS demo for a second. Why did Opus 4.7 struggle so specifically when it was adding new apps to the existing desktop?
It comes down to context decay and architectural memory. When you add a new app like a terminal to a simulated desktop, you fundamentally change the event listeners of the entire ecosystem. Opus 4.7 couldn't hold the entirety of that system architecture in its active memory simultaneously. As it focused on writing the terminal logic, it actively forgot how that new z-index impacted the old Finder windows it wrote 20 prompts ago.
It simply loses the architectural blueprint over time.
Exactly. Whereas Opus 4.8 maintains that blueprint across the entire workflow.
Mid-roll sponsor read placeholder, end of sponsor read.
All right, we're back.
We are back. Seeing what Opus 4.8 can build with WebGL and complex SVGs is mind-bending. But the real paradigm shift here isn't just the output.
No, it's the process.
It's how you actually instruct the model. We are officially past the era of the single magical mega prompt.
Totally past it.
This is about treating the AI like an active project partner.
This is the hurdle where most developers are still tripping up. You can't just drop into Claude Code and say, build a dashboard.
Too vague.
Way too vague. You need a highly specific, strictly defined goal. You should be saying, build a production-ready AI dashboard using React and Tailwind, featuring real-time workflow monitoring and specific error state boundaries.
The clearer the architectural goal, the better the final result. But you also have to force it to expand the project in distinct sequential stages.
Staging is everything now. You have it build the core layout first. You pause.
Right.
You verify that the Flexbox behaves responsively. Only then do you prompt it to add the analytics panels and the workflow tracking.
You have to force it to generate step by step, rather than letting it try to swallow the entire application at once.
Exactly.
Which brings us to the new Claude Code integration features. Because this is where the workflow magic actually happens for developers.
This is the best part.
When it acts as a senior software architect, it's not just generating text. It actively plans, reviews its own logic, writes tests for that logic, and fixes internal issues.
Yep.
All before it ever moves to the next stage of the development cycle.
It alters the entire development loop. With high-effort control enabled in Claude Code, you literally instruct it to create a development plan document first.
Like a real architect.
Exactly. It will identify package dependencies, flag possible security risks in the auth flow, and map out the API endpoints before it writes a single line of executable code.
Okay, but I have a pushback on this entire process.
Let's hear it.
If we have to meticulously tell the AI how to plan, how to review, and how to test every single step of the pipeline, aren't we just doing the heavy project management ourselves? The exact mental labor we hired the AI to take off our plates.
That's a very fair critique. And honestly, it was a huge complaint during the beta testing.
I can imagine.
And that is exactly why Anthropic introduced hooks into the API framework. Hooks are automated checkpoints that pause AI actions for human review or programmatic validation.
Specifically, the pre-tool use hooks and post-tool use hooks.
Right.
Let's unpack how those hooks actually function in a real workflow.
Think of them as physical checkpoints wired directly into the execution loop. You don't have to manage every single step manually anymore.
Okay.
You set a pre-tool use hook that automatically pauses the AI before a risky operation executes. Say, before it runs a terminal command that alters a database schema.
Oh, that's smart.
The API fires a payload to you, you approve it, and it continues. Or you use a post-tool use hook to run a test suite immediately after it finishes a component.
So it automates the safety check.
You automate the management boundaries instead of manually prompting it every 5 minutes.
Like setting up guardrails before it hits the gas.
Yeah, you give it the autonomy to drive the project, but with strict cryptographic safety boundaries in place.
We need to do a reality check now.
Always a good idea.
We've painted this beautiful picture of an autonomous, tireless software architect. But there is always a catch with these rapid AI advancements.
Oh, there are definitely trade-offs here.
What actually happens when high-effort reasoning meets real-world localized constraints?
The immediate constraint every dev will feel is the token usage. Those long reasoning sessions we praised, they make this an incredibly expensive model to run at scale.
Because it's thinking so much.
High-effort control burns through input and output tokens at a rate we haven't really seen before. The internal chain of thought is just so dense.
And it isn't just expensive financially, it's tangibly slower.
Noticeably slower. If you are used to the instantaneous generation of Opus 4.7 or Claude 3 Haiku, this will feel like a step backward in speed.
It takes time to think.
Planning complex architectures takes real computational time. If you ask it to refactor a massive code base, you're going to be staring at a thinking indicator for a while.
And despite all this extended reasoning time, workflow errors still happen quite frequently.
They do. It's not flawless. Complex multi-file projects still suffer from broken logic occasionally.
You'll find missing connections between back-end routes and front-end components.
Yeah, manual human review is still absolutely essential here. You cannot blindly deploy what it builds.
Using Opus 4.8 on high effort is like stacking Lego blocks of data.
Right.
But hiring a premium contractor to do it. The house is undeniably better, but you're paying them by the hour just to stand there in your living room and think about where the next block goes.
That's a brilliantly accurate way to describe the latency trade-off.
It really feels that way.
And we also have to acknowledge that it doesn't sweep the board in every category.
Right, there's competition.
Gemini 3.1 Pro is still demonstrably better at generating deeply advanced SVGs and handling multimodal visual inputs.
And GPT 5.5 and Codex still often win out in purely terminal-heavy, deeply obscure coding tasks.
Yep. The general consensus from the community seems clear. Opus 4.8 is a highly refined, incremental upgrade focused on stability.
It is not a revolutionary AGI-level new generation.
Definitely not.
But let me ask you about that financial trade-off. If I'm running a startup, does the time saved in debugging hallucinations actually justify the massive token cost of high-effort control?
It depends entirely on your developer hourly rate. Human debugging time is incredibly expensive and emotionally frustrating.
So true.
AI tokens are pricey, but they're usually still cheaper than a senior developer spending 4 hours tracking down a phantom memory leak.
That makes sense.
If Opus 4.8 prevents structural failure early in the planning phase, it easily pays for itself.
So, better code quality, but definitely watch your wallet.
Absolutely. You want to keep a very close eye on those billing dashboards when you leave a Claude code session running.
Let's pull back and recap the big ideas we covered today.
The main takeaway from reviewing Opus 4.8 is undeniably clear. Anthropic is proving that the future of AI isn't just about generating faster code snippets.
It's way beyond that.
The future is stable, agentic workflows. It's about long session stability across complex multi-file projects.
Giving the model the space to actually reason through a problem.
Exactly. It changes how we interact with these systems entirely. We are moving from single-turn chatting to continuous collaboration.
It is a profound shift in human-computer interaction.
I want to leave you with a final thought today. Something to mull over as you build out your own projects this week.
Yeah, think about this. If AI models are getting this good at autonomous coding, but they increasingly require precise staging, sophisticated hooks, and high-effort architectural prompting to stay on track, is the most secure tech job of the 2030s going to change? Are we moving to a world where the ultimate tech role is AI project manager rather than traditional software engineer? 2-sec silence. Thank you for joining us on the deep dive today.
It's been great.
We highly encourage you to try pushing your own AI workflows this week. Move away from those single prompts and try managing a multi-step, complex project using effort control. Take care of yourselves and keep building the future.